Namaste Coders. I Namaste Coders. I hope you are fine. So today is 7th March and we have done with today's problem of today. The video is uploaded on my YouTube channel. You can go through the video. The link will be given, the link of the playlist of whole videos of the problem of today is given in the description. Also, this video is a part of LeetCode 75 series in which we are going to solve all the problems of LeetCode 75. These 75 problems are the most important problems of DSA, which is most probably come in your interview, right? So let's begin with the problem. Today's problem. So we have already solved the first problem of all the topics, and we are started with the second problem, and we have solved the second problem till here. Now we are going to solve the second problem of graph BFS. Along with these videos, I have also created a WhatsApp group in which we can connect to the different. We can create a community. We can use that group for doubt solving, solving some problems, discussing algorithms, or creating some good projects for our resume as well as the freelance work. So if you want, you can join the WhatsApp group using the link given in the description. It's completely free, so I suggest you to just join the WhatsApp. Okay, so let's start with the problem. Today's the problem is rotten orange. You are given an m cross n grid where each cell can have one of the three values. 0 represent the empty cell, 1 represent the fresh orange, and 2 represent the rotten orange. Every minute, any fresh orange that is directionally adjacent to the rotten orange become rotten. Return the minimum number of minutes that must escape until no cell has fresh orange. If this is impossible, return -1. So the question is pretty straightforward. We have given a grid in which, let's say, this is 3 cross 3 grid. Let me make it here only. This is a grid. This is a 3 cross 3 grid. 2 means a rotten orange, so it's a rotten orange. 1 means orange. 1 means orange, and 0 means nothing. 0 means nothing. 1 means orange and orange. So how many minutes will it take to make all the orange rotten? So in first minute, this will get rotten and this will also get rotten. In second minute, this will get rotten, this will get rotten. In third minute, this, and in the fourth minute, this, right? So it will need 4 minutes to rotten all the oranges. So this is the question. This is a graph question, right? Because we need to do breadth first search. But what we need to do? Breadth first search to solve this problem. For a graph, there are two type of algorithm: DFS and BFS. So if you are not aware of these two problems, I have also already discussed in a detail about these two algorithms. You can go through those videos as well. I have already uploaded those videos in the LeetCode 75 series, right? Okay, so let's start with the I have already solved the problem, so let me explain to you in a detail, right? Okay, so this is a BFS question. What we need to do, first of all, we have created two direction arrays. This is 0 1 means we will go to the left, 0 1 means we will go to the right, 0 -1 means we will go to the left, 1 0 means we will go up, and -1 0 means we will go down. So this is the direction array. This is a 4 directionally adjacent, so we will create the 4 directions. Now this is in the main function. We have created a queue. This queue is required for doing the BFS. M is the size of grid, M is the width, M is the number of rows and n is the number of columns, right? Phrase, currently we have 0 phrases. Okay, now we will iterate through all the cells and check if there is a orange, is a fresh orange, so we will increase the number of fresh, and if there is a rotten orange, we will push that rotten orange in the queue, right? So we are in the minute will be initiated as 0 and label will be initiated, so L is the length of queue. Okay, so at any minute all the orange which is inside the queue can roten their adjacent orange. Okay, so let's say we are at the second minute and these all orange are getting roten, and inside the queue the 2 oranges are there, so they can roten this orange only because there is no adjacent. So let's say we are at the this minute 1. These 2 orange will be present in the queue, okay, because these 2 are currently roten by this orange. Okay, now these 2 oranges can roten this orange and this orange. So now at minute 3 these 2 oranges are inside the queue and they can roten this orange. Now at the minute 3 this orange is inside the queue because this is currently roten, right? So this cannot roten this orange. So if I explain to you again, at the first we will put inside the queue all the roten oranges, then by every passing minute it will get roten its adjacent oranges. So these 2 oranges will get roten and these will put inside the queue. So these oranges are inside the queue, so this will roten these orange. So now these oranges are inside the queue, so this will roten this orange. So this orange is inside the queue and this will roten this orange. So this is how the queue will gonna work. Queue will gonna help us. Okay, so L is the size of queue. We will increase the minute because at the first minute we will go through all the oranges which was presently inside the queue before this minute will increase. So if fresh is greater than 0, that means a fresh orange is present in our grid. We will do the breadth first search. We will go through all the neighbor adjacent oranges. We will check the boundaries and we will check if the orange is currently fresh or fresh, and then if it is a fresh, we will decrease the fresh, we will push the fresh orange inside the queue and we will make it a roten, right? And we will tell if fresh is equals to 0. If fresh is not equals to 0, that means there will be some orange which is not directly or indirectly connected to a roten orange. That means that orange will never get a roten. Okay, because there is no connection between that orange and the roten orange. So we will return -1 in that case. And if all the fresh orange is getting roten, we will return the minimum. Minimum is, it's not minimum, but it's a minute. Okay, so that's all inside this problem. So if you have any doubt, you can ask me directly in the comment section, or you can join the WhatsApp channel and you can connect with me through WhatsApp. Okay, if you have any suggestions for me, you can share those thoughts, valuable insights for me inside the anywhere you want, right? So thank you. This video is a part of our LeetCode 75 series, in which we will gonna solve all the LeetCode 75 problems. So I hope you have a good day. Thank you. Bye.